Okay, hello everyone in a new video. So we have reached part 6 of chapter 11, which is the chapter of pressure in liquids in the third unit of mechanics. In this one we are going to solve some exercises. So exercise number 11, a hydraulic jack is an application on the hydraulic press. It is used to lift loads as cars. Document 1, so they mentioned document 1, now we can use it. Shows a hydraulic press containing oil. Both branches are closed with two pistons of negligible mass and of respective cross-sectional areas S1 and S2. Choose the correct answer. So here for sure justification is required whenever it applies. The functioning of the hydraulic press is based on which law? So we have Archimedes' principle, Pascal's theorem, and Hooke's law. So we can directly eliminate Hooke's law because it's related to springs and not liquids. Then we are left with Archimedes' principle and Pascal's theorem. So since the pressure at this branch is transmitted to the other pressure, to the other branch, so we are talking about the transmission of pressure due to a liquid, which is given by oil in this case. So we are interested in Pascal's theorem. So the correct answer is Pascal's theorem. So in this case the correct answer is given by B. Now in number 2, the unit of pressure in the SI is, so this is important, A Newton per meter square, B Newton per centimeter square, C Newton per meter. So first let's eliminate this, so because this represents the unit of the stiffness. So both of these A and B represent the unit of pressure, because pressure is given by force over area. So Newton per centimeter square is indeed unit of pressure because it's force over area, but this is not the SI unit of pressure. The SI unit of pressure is given by Newton per meter square. Newton per meter square. So let's say that the unit of pressure in the SI is given by so the correct answer in this case is given by A. Now number 3, a force F1 of magnitude F1 is equal to 100 newtons is applied normally on the first piston, which has cross-sectional area S1 is equal to 5 times 10 to the power minus 4 meters square. The pressure exerted on the small piston is, so we have the following answers. In order to know which of these correspond to the value of the pressure, we need to calculate the value of the pressure, knowing that at this branch, so we are interested in determining the value of the pressure. We have the value of F1 and S1. We know that pressure, force, and area are related via the following formula. Pressure is equal to force divided by area. We know the value of the force, and we know the value of the cross-sectional area, so we can directly determine the value of the pressure because it's given by P is equal to F divided by S. F carries the index 1 as well as S1, so P will carry the index 1. The value of F1 in the SI is given by 100, and the value of S1 is given by 5 times 10 to the power minus 4. Now plugging this fraction on the calculator, then the value of P1 is given by 2 times 10 to the power 5. Since both F and S are expressed in the SI, so the value of P will be in the SI, which is in Newton per meter square. And usually this unit is denoted by Pascal. Then P1 is equal to 2 times 10 to the power 5 Pascal. So P1 represents the value of the pressure exerted due to the pressing force F1. So in this case the correct answer is C. Now number 4, the force F1 vector allows to maintain a car at equilibrium as shown in document 1. The force F2 exerted on the large piston must have a magnitude. So we have the following choices. So notice that all of these are combinations between F2, S2, F1 and S1. So for sure, in order to determine which of these is the correct expression, we need to use Pascal's theorem. So let's say according to Pascal's theorem, we have that the pressure at the point 1, so this is the pressure at the point 1, is equal to the pressure at the point 2. Now the pressure at the point 1 is given by F1 divided by S1, and the pressure at the point 2 is given by F2 divided by S2. And now in this case, so in order to compare this expression with the given expressions, let's first put them in one form. So let's get rid of the denominators here and here and here as well. So let's put all of these expressions as the same as of part C in order to compare. Now here in this case, if we cross multiply, we have that F1 multiplied by S2 is equal to F2 multiplied by S1. So this is the correct expression. Now we need to convert these expressions in the following form, so we need to get rid of the denominators. So here in this case, F2 is not divided by anything, so it's divided by 1. So if we cross multiply, then we have F2 multiplied by S1 is equal to F1 multiplied by S2. So this is for A. Now as for B, notice that here F2 is not divided by anything, so it's divided by 1. So if we cross multiply, 1 multiplied by F1 times S1, it will remain the same. So F2 multiplied by S2 is equal to F1 multiplied by S1. So in this case, as we can notice that, first of all, C is not the correct answer because F2 is not unknown. We have that F2 is multiplied by S1, so we can directly eliminate this. Now as for part B, F2 is multiplied by S2, but here in this case F2 is multiplied by S1, so we can directly also eliminate this. And as for A, we have that F2 multiplied by S1 on one side, so this is correct. On the other side we have F1 multiplied by S2, so which is the same as our answer, which is given by F1 multiplied by S2. So let's erase these and let's write here but. Now we know that this is the correct answer, but on the other side, so this is our calculation. Let's say F2 is equal to F1 multiplied by S2 divided by S1, and here it's divided by 1. So if we cross multiply, we have that F2 multiplied by S1 is equal to F1 multiplied by S2, and this can be written as, if we drag this to the left hand side and we drag this to the right hand side. So in other words, if we flip these expressions, we have that F1 multiplied by S2 is equal to F2 multiplied by S1. So notice that these two expressions are in agreement, which means that the correct answer is A. So exercise number 12. Consider a U-tube of uniform cross-section S. So by uniform it means the same. So here the cross-section S stands for the area. So what's meant by the same cross-section? So notice that the U-tube has two branches. So let's say that this is the branch 1 and this is the branch 2. Both of them has a surface area. So this is the surface area of S1 and this is the surface area of S2, of branch 2. So in this case it is of uniform cross section, so both surfaces areas are given by S and they are equal. Containing mercury, so in one of the two branches we put a quantity of water of volume V is equal to 80 centimeter cube. So this is water, and the volume of this water is given by V is equal to 80 centimeter cube. Knowing that centimeter cube is not the unit of volume, in order to convert from centimeter cube to meter cube, we simply multiply by 10 to the power minus 6. Then 80 multiplied by 10 to the power minus 6. then the volume of this quantity of water is given by 8 times 10 to the power minus 5 in the SI, which is given by meter cube. And here they are telling us that water and mercury are immiscible. So immiscible, it means that they doesn't mix with each other. Then at equilibrium, the height of water is h is equal to 40 centimeters. Knowing that centimeter is not the SI unit of length, in order to convert from centimeters to meters, we simply divide by 100. Then 40 divided by 100. Then the height of this layer of water is given by 0.4 meters. And that of mercury above the surface of separation of the two liquids is h, so this is h. Given that G is equal to 10 newtons per kilogram, which means that we are performing this experiment on the surface of Earth. Okay, the atmospheric pressure, P0, is equal to 102,000 Pascal at Beirut. So in particular, this experiment is being performed at the city Beirut. The density of water is given by 1000 kilogram per meter cube, and the density of mercury is given by 13,000 kilogram per meter cube. Now choose with the justification the correct answer. So for sure here we need to justify. So the pressure PC at C is A greater than that at B, equal to that at B, smaller than that at B. So in other words, we need to compare the pressure at the point C with the point B. So notice that here in this case the point C is located at a horizontal level lower than that of B, but notice that C and B are not at the same liquid. So we cannot say that as the depth in a liquid increases, the pressure exerted by the liquid increases, because here simply B is located in mercury in water, while the point C is located in mercury. But notice that since you are interested in the pressure, so let's consider the point C and look upward. So notice that the point C is open to the atmosphere, then it's submitted to the atmospheric pressure. As for the point B, it's also open to the atmosphere and submitted to the atmospheric pressure. Then let's say here that since C and B are submitted to the atmospheric pressure, which means that the pressure at the point C is equal to the atmospheric pressure, which is denoted by P0, and the pressure at the point B is equal to the atmospheric pressure, which is denoted by P0. In this case, we have that the pressure at the point C is equal to the pressure at the point B, and the correct answer in this case is given by B. Now, as for number 2, the value of S is given by 3,200 centimeters square, 0.5 centimeters square, or 2 centimeters square. So in other words, in order to correct the correct value, we need to determine the value of S. What does S represent? S represent the cross-section area of the given U-tube. So either we can calculate the cross-sectional area from branch 1 or from the second branch 2. So for example, we can think about that this surface area appear in the following equations, that P is equal to F divided by S. But here in both branches, we don't have any applied force, so we cannot use this method. But notice that here they are giving us the volume of the quantity of water, so we know the volume. Moreover, we know the height, which is given by 0.4 meters, which is 40 centimeters. So it's left to determine the cross-sectional areas. Now actually, so we know the volume of this water and we know its height. So what's the shape of this solid or of this quantity of liquid? So looking at the U-tube in 3D, we can notice that. So let's consider this is the point B, this is the point A. So actually it's not a rectangle, however, it's given by the shape of a cylinder like this. So in this case, water is contained in the cylinder. So here we have water. And you know that the volume of the cylinder is given by V is equal to S, which is the cross-sectional area, multiplied by H. We know the value of V and we know the value of H. We are interested in determining S. Then let's write down that V is equal to S multiplied by H. I repeat, what does each quantity represent? Here we are, this volume is the volume due to cylinder, containing the amount of water. This is the point B at the top of the cylinder. This is the point A at the bottom. The volume V is given by 8 times 10 to the power 5 meter cube, and we know the value of H, so it's left to determine the surface area S, or the cross section, which is given by this, and it's equal to this. So knowing that we are interested in determining S, so constructing the triangle of this formula, here because we have multiplied and V will be at the top, S and H are at the bottom, we are interested in determining the value of S. Putting our hand over S, then S is given by V divided by H. Now the value of V in the SI is given by 8 times 10 to the power minus 5 meter cube. And the value of H in the SI is given by 0.4 meters. Plugging this fraction on the calculator, then the value of S is given by 2 times 10 to the power minus 4. Now since both V and H are in the SI, so the value of S will be in the SI, which is meter square. Now notice that here, because V is expressed in meter cube and H is expressed in meters, so what's the unit of S? Meter cube divided by meter, which is equal to meter square. Okay, but notice that all of the given values are in centimeter square, so in order to calculate this calculated value of S with the given value, we need to convert from meter square to centimeter square, and this is done by multiplying by 10 to the power 4. Then 2 times 10 to the power minus 4 times 10 to the power 4. Then the value of S in centimeter square is given by 2. So S is equal to 2 centimeter square, which means that the correct answer in this case is given by C. So S is equal to 2 centimeter square. Let me make some space here. Now in number 3, the total pressure PA at A is, then in other words, we need to determine the value of the pressure at the point A. Then we consider the point A and we look upward. Notice that the point A is submitted to two pressures. The pressure due to the layer of this liquid, which is water, and to the atmospheric pressure that is being applied at the point B and transmitted to the point A according to Pascal's theorem, since what is separating A and B is a layer of liquid. Now here we are interested in the total pressure. So let's say that A is submitted to the pressure of water and to the atmospheric pressure. So in this case, this statement is important, and usually they give it half a mark. So half a mark for this statement. So the total pressure at the point A is equal to the pressure due to water, let's denote this pressure by PW, plus the atmospheric pressure, which is denoted by P0. Since PW is the pressure due to liquid, so it's the density of the liquid times G times H. The density of liquid, so this liquid is water. The density is denoted by rho water, multiplied by G, multiplied the depth at which we are calculating the pressure, which is denoted by H, plus P0. The value of the density of water is given by 1000. The value of G is given by 10. The value of H is given by 0.4 from here. Plus the numerical value of P0, which is given by 102,000. Now plugging this expression on the calculator, it's given by 4,000 plus 102,000. Since this is expressed in Pascal, which is the SI, and this is in the SI, so the value of PA will be in the SI, which is given by Pascal. So it's given by 106,000 Pascal. So the total pressure at the point A is given by 106,000 Pascal. And in this case, the correct answer would be C. Now, as for number 4, the total pressure at D is equal to that at A. So they are telling us that the pressure at the point D is equal to the pressure at the point A. So for sure, we need to use the relation that PD is equal to PA. So let's write that the pressure at the point D is equal to the pressure at the point A. And this is reasonable because that both points D and A are on the same horizontal level, and it is at equilibrium, and they are in the same liquid. So the point D is in mercury, while the point A, above the point A we have water, below the point A we have mercury. So whenever we are interested in knowing or determining the point in which liquid it is, we always look downwards. So notice that the point A is in mercury. So I'm just justifying why the pressures at the point D is equal to that at A. For sure we are talking about the total pressure. However, they are asking about the value of H is approximately equal to. So we need to calculate the value of H, starting from this relation. Now, because we are interested in the pressure, so let's consider the point D and look upward. So let's say that D is submitted to the pressure of mercury and to the atmospheric pressure. So this statement is important and they usually give it half a mark. So the pressure at the point D is equal to the pressure due to mercury. Let's denote this pressure by PHG plus the atmospheric pressure, which is denoted by P0. Now PHG is the density due to a mercury, which is given by the density of the liquid times G times the depth at which you are calculating the pressure. So the pressure of mercury is denoted, the density of mercury is denoted by rho Hg multiplied by the value of G multiplied by the depth at which you are calculating the pressure, which is small h, plus P0. Now as we can notice that since we are interested in determining the value of H, for this reason we have determined the total pressure at the point D, and also because they are telling us that the pressure at the point D is equal to the pressure at the point A. So now this quantity H appears in the expression of the total pressure at the point D. And we also determine the value of PA, which is given by 106,000 Pascal. So now we have that PD is equal to PA. Now the expression of PA is given by this instead of replacing this. So also you can replace this in order to determine the value of H. But I will use this expression. I repeat, you can also use this one. Now PD is given by this expression. So on the left hand side we'll write rho Hg multiplied by G multiplied by H plus P0, which is equal to PA. PA is given by this expression. Now as you can notice, here we can simplify P0 with P0. Then it's given by rho Hg multiplied by G multiplied by H is equal to rho water multiplied by G multiplied by H. And here we can simplify both sides by G. So it's given by the density of Hg, which is mercury multiplied by H, is equal to density of water multiplied by capital H. And knowing that we are interested in determining the value of H, so let's tabulate H. Now rho Hg multiplied by H is equal to rho water multiplied by capital H, knowing that we are interested in determining the value of H. So what's the type of this equation? This is a linear equation in one unknown. The unknown is given by H. How do we solve this equation? We put H on one side and all the other numbers on the other side. So before dividing by rho Hg on both sides, let's replace some values. So the density of rho Hg is given by the 13,600 in the SI multiplied by H. The density of water is given by 1000 and the value of H is given by 0.4. So now we have determined the value of 13,600 H, but we are interested in determining the value of H. So dividing both sides by 13,600, then the value of H is given by this fraction. Now plugging this fraction on the calculator, then the value of H in the SI is given by 0.029. Since all of these quantities are expressed in the SI, so the value of H will be in the SI, which is meters. But notice that all of the given values are in centimeters. In order to compare the calculated value with the suggested values, we need to convert from meters to centimeters, and this is done by multiplying by 100. Then 0.029 multiplied by 100. Then the value of h in centimeters is given by 2.9 centimeters. Then h is equal to 2.9 centimeters. And in this case, the correct answer is choice A. Now finally, as for part 5, we repeat the same experiment at Al Barouk mountain where the atmospheric pressure is less than P0. So previously we were performing this experiment at Beirut. Now we repeat the same experiment at Al Barouk mountain. So notice that Beirut compared to this mountain is located at a horizontal level which is lower. So for this reason the pressure at Beirut is greater than the pressure at pressure at Al Barouk mountain. For this reason here the pressure is less than that of P0. They are asking me again about the value of h. So does it remain the same, increases or decreases? So in order to answer this question, we need to find a relation for h in which it depends on several physical quantities. So notice that here in part 4, we have determined the following relation, which is given by rho hg multiplied by h, which is equal to rho water times h. So first let me explain. When going to Al Barouk mountain, what will happen here? So the quantity of mercury will not change, nor the quantity of water. What will change actually the atmospheric pressure, which is being submitted to the points C and B. So now, in the new atmospheric pressure, let's suppose that it's denoted by P prime 0. So this atmospheric pressure corresponds for the new place, which is the mountain. Now C in this case will be submitted to the new atmospheric pressure, which is P prime 0, as well as for the point B. But notice that in this relation, P0 on the left hand side cancel out with the P0 on the right hand side. Although independently PD depends on P0 and PA independently depends on P0. So here if we need to write the new expression, then it will be given by P prime 0 and P prime 0. But since it cancel out on both members or on both sides, then it doesn't play any role in the value of h. So here, let me also say that we also have that the pressures at the point D is equal to the pressure at the point A. So now rho hg multiplied by g multiplied by h plus P prime 0 corresponding for the new pressure, and rho water times g times h plus P prime 0. Now also P prime 0 goes out, cancels out with P prime 0. Then the value of h also is given by 2.9 centimeters if we repeat the same calculation. So for this reason, h will remain the same. Then h remains the same. Then in this case, the correct answer would be choice A. Now, exercise number 13. This exercise aims to show evidence of the variation of the pressure with the depth and the nature of the liquid. A diver is practicing an underwater diving in a lake of fresh water. Given the atmospheric pressure, the free surface of water in the lake is given by 100,000 Pascal. So the atmospheric pressure is given by 100,000 Pascal. And the density of fresh water, so here let me write fresh water, is equal to 1000 kilogram per meter cube, and given that G is equal to 10 newtons per kilogram, which means that we are performing this experiment on the surface of Earth. Number 1, the diver swims on the surface of water. Give the value of the pressure exerted on the ear of the diver. So in order to make this exercise clear, let me make the following sketch. So let's consider a container containing a liquid. The liquid in this case is given by fresh water, or the water of the lake. And here in number 1, they are telling me the diver swims on the surface of water. So let's consider the point A to be the diver on the free surface of water. They are telling me give the value of the pressure exerted on the ear of the diver. So this is the diver here. So we are interested in the pressure, so we consider the point A and we look upward. Notice that A is open to the atmosphere, so the ear of the diver is submitted to the atmospheric pressure. Then the value of the pressure is given by the atmospheric pressure. So we are in number 1. Let's say that the ear of the diver is submitted to the atmospheric pressure. So in this case, this statement is important, and they usually give it half a mark. So the pressure is given by PA, which is equal to the atmospheric pressure, which is given by 100,000 Pascal. And now in number 2, the diver goes down to a point where his ear becomes 10 meters below the free surface of water. So let's consider a horizontal surface below the point A, located at 10 meters. So what does H represent? H is the depth between the points A, the free surface, and the point B. So this is H. Now in this case, the diver is swimming at the point B. 2.1, the pressure exerted on the diver's ear increases. Why? So previously the diver was swimming at the point A, at the surface of the point A. Then he's swimming at the point B, which is located at a horizontal level lower than that of A. So knowing that as the depth in a liquid increases, the pressure exerted by liquid increases. So notice that here they are telling us why, so this is the justification, but another part of this question is given by how much, so we need to give a numerical value. So previously the diver was swimming at the point A, which is given by the pressure at the point A. Then the diver is swimming at the point B, and in this case the pressure is given by PB. So knowing that the pressure at the point B is greater than the pressure at the point A, but they are telling us by how much. So by how much the pressure at the point B is greater than the pressure at the point A. So in other words, they are asking about the difference PB minus PA. So, or in other words, they are asking about the variation of the pressure delta P. So let's say delta P is equal to the pressure at the point located at the lower horizontal level, which is given by PB minus PA. So if we know, we know the pressure at the point A, which is given by the atmospheric pressure. However, we don't know the total pressure at the point B, so it's more simpler to calculate delta P using the variation, which is given by the density of this liquid, which is given by lake. So delta P can be directly calculated using the density of the liquid times G times H, in which H represents the variation between the two levels corresponding for the points B and A. So the density of this liquid is given by density of fresh water or water of the lake multiplied by G multiplied by H, in which H represents the difference in these two levels. Now the value of the density is given by 1000. The value of G is given by 10, and the value of H is given by 10. Plugging this on the calculator, then delta P is given by 100,000. Since all of these quantities are expressed in the SI, so the value of delta P will be expressed in the SI, which is given by Newton per meter square, and usually this unit is denoted by Pascal. Then delta P is given by 100,000 Pascal. So what does delta P represent? Delta P represents the increase in the pressure comparing the points B and A. So the pressure at the point B is greater than the pressure at the point A by 100,000 Pascal, because now the diver is swimming at the point B lower than the point A by 10 meters. So now 2.2, if the diver swims at the same depth, would the pressure on his ear vary? Why? So now the diver is swimming at the same depth, so at the same horizontal level. They are asking us, would the pressure on his ear vary? So we are interested in the same pressure. So always such type of questions are answered using the rule of 3, which is given by same liquid at equilibrium. And either we say same pressure or same horizontal level. Since here we are interested in justifying why the pressure would be the same, because we are interested in the same depth. So we will eliminate this, and our answer would be, because the diver is swimming in the same liquid at equilibrium and in the same horizontal level, then in this case the pressure exerted on his ear will not vary, which means it remains the same. And here let me write that delta P given by 100,000 Pascal. So since the diver is swimming in the same liquid at equilibrium and in the same horizontal level, so with the same horizontal level, it's meant that the same depth. For this reason, then the pressure of all points of this depth is the same. In other words, it doesn't vary. Now as for number 3, the total maximum pressure that the ear can withstand is 250,000 Pascal. So P max, which corresponds for the total pressure that the ear can withstand, is 250,000 Pascal. Now 3.1, calculate the maximum pressure due to water that the ear can withstand. So the given is the total maximum pressure that the ear can withstand. So we have the total maximum pressure, and we are interested in determining the maximum pressure due to water. So the total pressure and the maximum pressure due to a liquid are related via the following formula. So if we consider the point B, since we are interested in pressure and we look upward, so the total pressure at the point B, which is given by PB, is equal to the pressure due to the layer of this liquid, which is the fresh water or the water of a lake, P water, plus the pressure at the point A. Now in this case, PB represents the total maximum pressure that the ear can withstand is 250,000 Pascal. So let me say that this is P max total, which is equal to P max water plus PA. So knowing that we are interested in the maximum pressure due to water, so we will keep this as a variable. Now the P max total is given by, so it's the maximum pressure that the ear can withstand is given by 250,000, which is equal to P max water plus PA. The value of PA corresponds for the atmospheric pressure, which is given by 100,000. Knowing that we are interested in determining this value, what's the type of this equation? This is a linear equation and one unknown. The unknown is given by P max water. How do you solve this equation? We put P max on one side and all the other numbers on the other side. So 250,000 minus 100,000 is equal to P max water. Then P max water is equal to 150,000. Since this value and this value are expressed in Pascal, so P max water will be in Pascal, which is the SI unit of pressure. Then P max water is given by 150,000 Pascal. So what does this value represent? The maximum pressure, not the total pressure, but the pressure due to water that the ear can withstand. So here we can say that this is P max total, but P max due to water, because we at the point B we have two pressures, the atmospheric pressure and the pressure due to water, is given by 150,000 Pascal. Now in 3.2, deduce the maximum depth H max that the diver can reach under water of the lake, and by deduce it means that we notice the previous part. In 3.2 we have determined the value of P max water, and we are interested in determining H max. So knowing that this pressure is due to a liquid, so it's given by the density of the liquid times G times H. The density of this liquid is given by rho fresh water multiplied by G. Since this carry the index max, then H will carry the index max, knowing that we are interested in determining H max. So constructing the triangle of this formula, here because we have multiply, then P will be at the top, rho, G and H here. We are interested in determining H, so putting our hand over H, this is rho L, then H max, H is denoted by H max, is given by P max water divided by rho fresh water multiplied by G. The value of the rho fresh water is given by, P max water is given by 150,000, and the value of rho fresh water is given by 1000 multiplied by 10. Plugging this fraction on the calculator, then H max is given by 15. Since all of these quantities are expressed in the SI, so the value of H will be in the SI, which is meters. Then H max is equal to 15 meters, which represent the maximum depth that the diver can swim, because his ear can withstand a maximum pressure given by 250,000 Pascal. Now in 3.3, if diving took place in seawater of density 1050 kg per meter cube, so now the density increases from 1000 to 1050,000. Would the diver be able to swim safely at the depth H max? Justify the answer. So now, okay, the pressure due to a liquid is given by rho L multiplied by G multiplied by H. So if the diver is swimming in the water of the fresh lake, so the maximum height, let me say it here, that P due to a liquid is given by the density of the liquid times G times H. And if the diver is swimming in the lake given by the density 1000 kg per meter cube, in this case he can swim at the depth given by H is equal to 15 meters. Now here they are telling us that he wishes to swim in the seawater of density 1050 kg per meter cube. So the density now changes from 1000 kg per meter cube to 1050 kg per meter cube. Would the diver be able to swim safely at the depth H max? So now if we construct the triangle of this formula, so here because we have multiplied, then P will be at the top, rho here, G here and H here. So now rho increases from 1000 to 1050 kg. Now notice that P and rho, let's consider rho and H. Rho and H are variables living in the same floor, so they are neighbors hating each other. So whenever rho increases, H will decrease. So now because rho increased from 1000 to 1050, then h will decrease. H previously was given by 15 meters, so expect that h will decrease from 15 to a number. So let's calculate this number. Now we will use the same expression, which is given by h max is equal to p max water divided by rho fresh water times g. So now h max, so this is the new maximum height, let's not decide by h prime max, which is equal to the pressure of max water divided by, now in this case, because he's swimming in the seawater, so let's replace rho fresh water by rho seawater, which is given by 1050,000 kilogram per meter cube. So this is seawater multiplied by G. Now the value of P max water is given by 150,000 Pascal, and the value of rho seawater is given by 1050 multiplied by 10. Now plugging this fraction on the calculator, then h prime max is given by 14.29. Since all of these quantities are expressed in the SI, then h prime will be expressed in the SI. So as we expected that h prime will decrease, so the maximum height have decreased from 15 meters to 14.29 meters. This is h prime max. So here what we can say, so h max is given by 15 meters, where h prime max is given by 14.29 meters. And now let's compare both values. So as we can notice that h prime max is less than h max. So what does h prime max represent? The depth that the diver can swim safely in seawater, which is less than h max, corresponding for the depth safe for swimming in the fresh of lake water. So in this case, the conclusion is that the diver will not be able to swim safely at this depth at the depth h max since h prime max corresponding for the seawater is less than that of the lake. So that's it for me in this video, guys. See you soon in another one.